The shaky winning directors of the movie Imitating a RoboCup Soccer Player Using Case-Based Reasoning are proud to present Case-Based Imitation, a sequel. Meet our software agent. It's trying to play Tetris, but as you can see, it's not having much success. The problem is that it doesn't know anything about Tetris. It's going to need to start learning if it has any hopes of playing this game well. If the agent doesn't know anything about Tetris, how will it learn to play? The agent is going to observe someone playing Tetris and learn that way. But if someone knows how to play Tetris, why don't they just program the agent? There are two main reasons why not. First, the person may not have the time. They need to program and test the agent, which would likely take much more time than simply demonstrating the behavior. Secondly, the person would need to have knowledge of computer programming, which not everyone has. You may be wondering how exactly the agent will observe the expert. The agent uses case-based reasoning and makes use of the assumption that similar problems tend to have similar solutions. In Tetris, the problem is the state of the board and the current piece it needs to place. The solution to the problem is how the agent moves and rotates that piece. Together, these problem-solution pairs are called cases and can be automatically generated by observing how the expert behaves in response to each encountered problem. After collecting a number of cases, called a case base, the agent can then play Tetris by itself. When it encounters an input problem, it can search the case base for a similar case and reuse the solution from that case. Let's see how the agent does after observing the expert. The first thing we notice is that it's actually moving and rotating the pieces, which is definitely an improvement over what we watched earlier. In fact, it actually seems to be doing a pretty good job. It's placing the pieces well and even completing a few lines. Not too bad for an agent that doesn't know any of the rules or the goals of Tetris. So the agent can play Tetris now, but what else can it do? As we saw earlier, when using a case base generated by observing a Tetris expert, our agent was able to learn to play Tetris. But is our agent only suited for Tetris? No, it's not. When we place the agent in a new domain, like simulated soccer, space combat, or a physical robot, we just need to exchange the Tetris case base for a case base suited for that domain. The key point is that we do not need to make any change to how the agent reasons or provide it with any domain knowledge. We are simply changing the data it reasons with. Let's have a look at the agent playing simulated soccer. The red team is made up of the original agents, and the blue team is made up of the imitators. As you can see, it is difficult to tell them apart. In these soccer cases, the input problems are what the agent can currently see in its field of vision, and the solutions are the soccer-specific actions like dashing, turning, and kicking. And here is our agent in a space combat game. The agent it's imitating turns until it can see another ship, and then shoots at that ship. Like the previous demos, the agent seems to be doing a fairly good job imitating this behavior. So far we've only described simulated domains, so now we will look at our agent controlling a physical robot. In this clip, our agent is imitating the behavior of an obstacle avoidance robot. Instead of high-level inputs, like we saw previously, the agent only receives inputs from its various sensors. It can then control its wheels to keep itself away from the various obstacles it encounters. Since all of the information the agent has is contained in its case base, we can even use the case bases to transfer knowledge between different domains. For example, if the agent observed a behavior in the robot domain, we can convert that case base so the agent can perform the behavior in the soccer domain. We just need to perform a mapping between both the inputs and the outputs of the two domains. This clip shows the agent in the soccer domain using the obstacle avoidance case base we saw earlier. As you can see, the agent is avoiding the soccer balls. Likewise, we can transfer an object tracking behavior from the soccer domain to the robot domain. Now instead of avoiding obstacles, the robot is moving towards them. Let's look back at the agent playing Tetris. Earlier we showed that after observing the expert, the agent was able to play fairly well. However, we didn't show you everything. If we watch the video a little further, we see that things start to go wrong. The problem is, once the agent makes a few mistakes, it ends up with a board configuration that is significantly different from anything that it has seen before. The expert is smart enough not to put itself in these situations, so no matter how long the expert was observed, it would never encounter certain problems. Luckily, our agent is not shy and is willing to ask for help when needed. When it is unable to find a similar case, it asks the expert to solve the problem and can then add that solution as a new case in its case base. Using this interactive tutoring approach, the agent is able to learn things it would not have been able to with observation alone. This is the end, but if you have any questions or comments, we'd love to hear from you.